Welcome to WIZnet TV. Have you ever wondered how computers talk to each other over the internet? It's like sending a package. Imagine you're sending a book to a friend. You wouldn't just throw the pages in a mailbox and hope for the best, right? That's where TCP, or Transmission Control Protocol, comes in. It's like the postal service of the internet, making sure your information arrives safely and in order. Just like an address label tells the postal service where to deliver your package, TCP uses special instructions called headers to ensure data reaches its destination. These headers contain important information that helps manage and deliver data packets, the small chunks of information that travel across the internet. Understanding TCP headers is key to understanding how the internet works. Think of it like this. When you send a message online, TCP breaks it down into smaller packets, each with its own header. These headers act like instructions, telling the receiving computer how to handle the data. They ensure that the data arrives in the correct order, without any errors, and to the right application. Now let's say your friend is expecting multiple packages, maybe a new game, a birthday card, and some groceries. How would they know which package is which? That's where ports come in. Just like different doors in a building lead to different apartments, ports help identify specific applications on a computer. Every device on the internet has thousands of ports. The source port in the TCP header tells the receiver which application on computer sent the data. It's like writing "from your name" on the package. The destination port is like the to address, indicating which application on the receiving computer should get the data. This ensures that, for example, an email you send goes to your friend's email inbox, not their music player. Imagine your book arrived as a jumbled mess of pages. TCP has a clever way of preventing that. Each byte, like a letter, in your data, is given a unique number called the sequence number. It's like numbering the pages of your book. This way, even if packets arrive out of order due to different routes on the internet, the receiving computer can use the sequence numbers to reassemble the data in the correct order. No more mixed-up messages. The sequence number ensures that all the pieces of your message, like chapters in a book, are put together in the right order at the destination. This is crucial for things like websites, where images and text need to be displayed in the correct sequence. How do you know your friend received the package? They send you a confirmation. Similarly, TCP uses the acknowledgement number to confirm receipt of data. It's like your friend sending a message saying, "Got it." This number tells the sender which data packets have been received successfully. If a packet is lost, the receiver won't send an acknowledgement for it. This signals to the sender to resend that specific packet. The acknowledgement number is like a return receipt, letting the sender know that the data has arrived safe and sound. This back-and-forth communication ensures that nothing gets lost in transit.